Okay, my advice, don't immediately jump to formula, step back, okay, and you have to analyze. Not a lot of courses that you learn need to analyze. 2 P04, this course, okay, those who are in second year, you require a bit of analysis. Okay, do you understand what is analysis, yes or no? Okay, let me talk to you something about study. In your education, there are a few steps. The first layer is known as what? Remember. The next layer is known as what? Understand. The next layer is what we call what? You need to what? The top layer, can't remember now. Okay. The longer the bar means it takes what? Longer time. Okay. The shorter the bar means it what? Takes shorter time. So first of all, you have to remember first, then you understand. After remembering, then you understand, then you what? Analyze. I'll give you an example. Can you remember the 10 Commandments? I can't. If you cannot remember the 10 Commandments, how are you going to understand what is the 10 Commandments? If you cannot understand the 10 Commandments, how do you know how to analyze the 10 Commandments? At the end of the day, how many commandments is the most important? 2. Are we clear? What are the 2? Love your neighbor like how you love yourself. Are we clear? And rule number 1, we all worship a one all God mighty. Are we clear? Okay, whoever you want to call it, it's up to you. Let's be clear. Right. Now, this is where analysis is. So analysis, you have to remember, you have to understand, then you have to what? Now you have to analyze. So that's why if you feel overwhelmed a bit now, it's okay because I felt overwhelmed before. Okay. Now let's start with the analysis. So now at the end of the day, we want to find VB, okay, when S is equal to 0.5 meters. Okay. So the thing now is this, okay, if we have the gear system down here, let me copy the diagram so you can see the diagram. Right? So if you were to see, we have to relate VB. Okay, VB. So VB we know is going in which direction, up or down? Initially, S is equal to 0, then later S is equal to 0.5. We know that VB is going which direction? This direction. Okay, that's our VB. And then if you were to look at VB, VB somehow is connected to which pulley? Okay, it's connected to D or C? D, yes or no? Right? So how to relate when you do how is S, okay, related to theta D? Is the first thing we ask ourselves. Okay. So we know S is equal to what? Theta D RD. Okay. And we are aware that RD is equal to, what is RD equal to? I think RD given to us is, from the diagram, the radius at D is 75 millimeters or 0.075 meters. Okay. And then we have to know what is our S. So S given to us is 0.5 meters. So now we can find theta D, right? So what if we know theta D now? Okay, so at the end, then later on, we also can write this out that omega C is equal to omega D, and this is because point C and D are part of a what? Or are points on a rigid body. So if you look at point C and point D, they are like infused together. Are we clear? Okay. There's no slippage. I write down here, no slippage. Okay. Later on, you'll come out with a term. Okay. You'll see this term. Okay. So we can also write, okay, then we are going to draw what is happening on pulley D. Hey, wrong button this way. So what I'm drawing down here, okay, this corresponds to pulley D. Okay, pulley D means this thing over here. Okay, so over here we have a velocity going up here. This is our VD, and we know that our VD is also equal to our what? VB. Okay, this distance from here to here is our RD, and this will be rotating at omega D. Now this we are analyzing based on motion. Okay. Okay. So given to us now, right? So what we know now is VB is equal to VD is equal to omega D RD. Okay, omega D RD. So this is the analysis that we have done. So we found the relationship of S, okay, and then how to relate S, right? To later on, we know that we have to relate to omega C, right? And then later on, we found the relationship that VB is equal to VD omega D RD. Okay. Okay. So let's recap what we are given. Okay. So we are given the expression, right? So I'll write this out again. So note, I'll keep the diagram so you can see what is going on the diagram, okay, and what we're trying to achieve down here. So we are given that alpha A is equal to what? 0.6 theta. Okay. So the relationship that we are that we know, right? So what are the terms that we know, right? We know that alpha is equal to d omega over dt. And then the next term we know, right? So this is like doing my side work. Again, I have not a clue where this is going, okay? And this is equal to omega is equal to d theta over dt. Why I write this first expression, right? Because we are given what? Right? We are given alpha A, right? That's why I write this expression. Then over here, somehow we have to relate. So we also know that later on we can calculate the what? We can calculate this expression. we can calculate what is our theta. So we later on, we also know that we can determine what is our theta. Then if we're going to equate the both expression based on dt, right? So we know that dt, which I've written earlier, this is equal to d omega over alpha, and this will be equal to d theta over omega. So finally, we have the relationship where we have alpha d theta is equal to alpha d theta is equal to omega d omega. Okay, so we have this expression. But note, the problem with this question that they make it a bit complicated is we are not given any time function at all. Can you see that? We are not given any time constant at all. Okay, so if we look at this problem, okay, note that there is no time constant info or time constant given when s is equal to 0.5 meters. We're not given any time constant. They did not tell us what time it will occur. Okay, we are not given what time it will occur. So from here, the only way to relate this is we have to determine what? We have to somehow determine omega A. Okay, we have to determine omega A when S, okay, somehow we have to determine omega A when S is equal to 0.5. What units is this in? 0.5 meters. Okay. So given the expression, we can focus, okay, from point A, from pulley, okay, from pulley at point A, right? We can use this expression omega d omega, and this is equal to alpha e theta, right? And we happen to be not lucky, but we know that over here, if we integrate, right? So given to us, initial condition, this is 3, this is omega A, right? We have d omega, and this whole expression is equal to 0. Now, when it will reach omega A, I have not a clue, but alpha is equal to 0.6. What is our alpha equation? Alpha is equal to 0.6 theta, okay, 0.6 theta d theta. Okay. So now we have not a clue what is the what? What is the upper limit? Okay, we don't know what is our upper limit. Okay. So I'm aware that you all have not learned pulley. Have you all learned pulley yet? Pulley system? Some of you? No? Yes? Okay. So probably you have learned. Probably have you guys learned pulley calculation in high school? Right? I remember I learned it in high school. Gee, that is a long time ago. So now, if we look at the pulley system, okay, we have one pulley here. So this is our pulley A. And then The previous question was focused on what? Was focused on gears. Now we are looking at pulley. Okay. So that's why I told you I don't pick easy questions. This is your pulley